Well, hello everyone, and welcome to another episode with your girl, Audrey Codner from GED Math Tutoring. Hopefully you guys are doing well this evening, this afternoon, this day. So, we are actually going to be looking at a couple of things tonight. So, we're going to see how much strength Audrey has to accomplish all this, which is going to be fun. So, there's two things we're going to hit. One is going to be looking at some of the problems that I keep seeing for geometry if you're thinking about taking the ASVAT or the GED. And I kind of see these problems keep popping up. So I said, you know what? I took it from someone's stuff, that I was helping out with, and I'm going to share this stuff with you. And then the last part is today alone, I had 3 different clients saying that they need help with rationalizing the denominator of radical expressions. So those are the 2 things that we're going to be working on today. And last time I checked, today's date is going to be May the 6th. 2025. Here we go. Now, just in case you don't know, Audrey's Notes is live and well. All the links are working. I got a few people that already purchased their notes. Thank you so much. Book 3, if I keep going on this route, book 3 will actually be ready by next week, which is this lovely thing right here. All right. So, hey, if you want to wait until this comes, that's fine. But guess what? A lot of people are starting to purchase it, and I hope you guys have a good time doing it. All right. So let's take a look. Yes, look at you. On time. Good job. So, here we go. Now, some of these things you're going to be like, oh, wow, Audrey, that's really easy. Most of the problems that I saw here were mostly like easy to medium type questions, okay? So I have roughly, what we got, 6, 7, 8, 9, 10, 11, like 12 questions. And it just seems like they're constantly the ones that you see a lot of. And there's probably going to be a few more. But I just wanted to kind of go over it a little bit, step at a time. All right, so the first one. I know it's kind of zoomed in here. So it says, in which quadrant does point 7, negative 8 lie? Okay, which quadrant will be 7, negative 8? So if you're wondering what is a quadrant, let me explain to you. When you have 2 number lines crossing at their origin, which is at the zeros, okay, that gives you the x-axis and what's called the y-axis. From left to right or horizontal is your x-axis. Up and down, or basically north to south, is your y-axis. And instantly it creates 4 sections. And the way it goes is the upper right, that's going to be your first quadrant. Then your upper left, that's your second quadrant. Then it goes your third quadrant, then your fourth quadrant. So it goes counterclockwise, but it starts at the upper right. Okay, so all the points in quadrant 1, the x values are positive and the y values are positive. For quadrant 2, your x values are negative and your y values are positive. Quadrant 3 here, your x and your y's are both negative. And then for quadrant 4, your x values are positive and your y values are negative. Okay. So where would 7, negative 8 lie? Where do you think? Hey, Bree, how are you? Okay. Some people are saying, all right. Some people are saying quadrant 3. Where do you think? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4? So some people are saying option D. Hey, Cookie, how are you? Hey, Evelyn, how are you? Link them in. Okay, unapologetic 4. Then we got 4. There's a shadow on your paper. I know, that's how it was printed. And paper costs money, so I was not going to print it again, okay? So it is going into quadrant 4, because if we're saying we have 7, that's a positive number, and 8 is a negative number, it's going to end up into quadrant 4. All right? So now we're taking a look at this one. Now we're switching over to angles, and we're saying, what is the measurement of angle D? And you're like, ooh, what's going on? Take a look at the whole thing. Okay? Take a look at the whole thing. All right, so right now we're kind of like revisiting ASVAT geometry. Oh, well, thank you. Thank you for the gifts. I appreciate you. You don't have to give me anything. All right, so I have user, yes, is saying 50, okay, far from D. Jeanette is saying A, which is 50. Is it Natalie or Natalie? Saying 50. When are we doing radical expressions? Actually, I did radical expressions, but we're going to be doing rationalizing the denominators tonight. Yes, Miss Taylor's in here. She's waving to you. Okay, so for those that don't know Miss Taylor from Impact Math, she's that other person I keep telling you about. Okay, almost every time. You guys can tell her. All right, so if you, in addition to me, if you also want to follow along, especially during the day, I'm not sure if you're also going to go tonight, Evelyn. Tonight for me might not be like a 2-hour venture. If I got an hour and 15, that would be great. So if you're looking at the TEAS test, the ASVAT, the GED, okay, you can also follow Impact Math. I know during the week she is on at 1 p.m. Central Time. So, and sometimes she comes on at night. So we'll just keep an eye on that. All right. So now we got 50. Eric says 50. So it is going to be 50. Now we got 50. Eric says 50. So it is going to be 50. Is going to be 50 all day. Doesn't make any sense. None whatsoever. All right, let's see what we got here. All right, there we go. Now we got them some juice. All right. So if you take a look, we're saying from here to here, okay? This part of the circle is 310 degrees, okay? If we all know the total is 360 degrees. So if you know this, all you have to do is subtract the 310 from that and you will get your 50. All right? See how so far, just those 2 problems, you should be done in like 30 seconds. Okay? Just by knowing this little bit of information, you should be done in like 30 seconds. And they're really calculating roughly like 1:10 per problem. So all this extra time can go into some other problems, okay? That's why I always, when I give you time to work on a problem, I'll give it to you like 1:10 seconds. That's the reason why. So we can practice up when it's time for you to take a test, and a lot of you guys generally get the answers rather quickly. All right, so looking at this, 2 angles are equal in a quadrilateral, okay? The third angle is equal to the sum of the 2 equal angles, and the fourth angle is 60 degrees less than twice the sum of the other 2 angles. What are the measures of the 4 angles? And you're probably saying, okay, you were speaking English, and now you just lost me, right? These are those word problems that a lot of people, when they see the words right away, they want to shut down. But whenever you get crazy, let's draw a picture. So first off, we need some terminology. Quadrilateral. Quad means 4. Okay? Doesn't matter. 4-sided figure. Okay? They didn't say if it was going to be a rectangle. They didn't say it was going to be a square. They didn't say it was going to be a parallelogram, a rhombus. They didn't say any of that. But they're just saying we have two angles are equal in a quadrilateral. Okay? So we got two of them are exactly the same. So let's say this is my x and this is my x, right? I'm just throwing stuff out there. The third angle is equal to the sum of the two equal angles. All right. Sum means addition. Two equal angles. So that means this third one, if I add these two together, it will equal this third one. So what is x plus x? Okay. We're just solving some questions. Good. So x plus x gives me 2x. So that third angle is equal to the sum of the two equal angles. Okay? Then they say the fourth angle, which is this one, okay, the fourth angle is 60 degrees less than twice the sum of the other three angles. This is a slight mouthful. Okay, this is a slight mouthful. So, if we're saying 60 degrees less than, all right, less than, that's not an inequality. So, let me come over here for y'all. So, when we're talking less than is under subtraction. But I know a lot of people generally get less than and is less than mixed up. When they say something is less than, we're talking inequalities. If they're just saying less than, we're talking about subtraction. Now, when I hear twice, that's multiplication. Okay? So something that's happening twice, that means you are multiplying it by 2. So now, if we think about it, if we really think about it, let's move that onto the side. We're talking about 2 times the sum of the other 3 angles. So if I do this plus this plus this, that will give me 4x. Trust me, I'm going to show you the shortcut in a moment. And they said less than, so 60 less than. So that means I'm minusing 60. Okay? Now, we could do all this and waste a lot of time. Are you ready? Let me show you the shortcut. So first off, they said 2 angles are equal in a quadrilateral. Take a look at your answer choices. Which ones doesn't have 2 angles equal to each other? Which one does not have 2 angles equal to each other? There you go. A and B is completely out. Good. Hey, Janice. Completely out. They don't have 2 of them. So boom, process elimination. Then they said the third angle is equal to the sum of the 2. So if the third angle, I need to add them. So if I do 35 and 35, last time I checked, that gives me 75? No, that gives me 70. So that's why C is out and D is up. Did we even have to do all of this? No, but this is what you guys do. You're just like, because we were trained. Guys, we were trained as kids to, you have to show all your work. You need to step it up. You got to display everything. Remember, when you're taking these type of assessments, it's not the same as taking a test in the classroom. This is two different processes, okay? So when it comes to these type of tests, it's like use common sense and then try to apply what you know to the situation. Okay, you know the word sum means addition. Okay, you could paint a picture and do all this and have it equal to something. And what that something will be is 360. Because for angles, for a quadrilateral, all the angles are summed up to be 360. Okay, so we could do that, but we didn't have to. All right. Okay, so we can get straight to it, right? I know. That's probably what everyone earlier on said. Oh, okay. Because when you do your answers, most of the time your answer is going to be multiple choice. They just care, did you pick A, B, C, or D? Sometimes there's an E, right? Which one did you pick? That's all they care about. Okay, so they can get you in that right zone and you can take it and run with it. All right. So now, the radius of a circle is 2 inches. What is its approximate circumference? That's huge. Okay. The circumference, I'm going to try my absolute best to draw a decent circle. A little lopsided, but here we go, right? The circumference, that is the exterior. It's almost like if I wanted to, I know this is really cheap, but if I wanted to gift wrap this highlighter, just work with me, okay, people, just work with me. So if I wanted to gift wrap this, I want to know the wrapping. I want to know how much wrapping paper I will need to gift wrap a highlighter. I don't know. It was right there. I just grabbed it. Okay. They're telling me radius. What the radius is from the center of the circle to any part on the circle. So it's halfway. Not really halfway, but you know what I'm saying. So this is your radius. Sometimes they will give you what's called the diameter. The diameter is a chord that goes through the center of the circle, but it goes from, and it hits one end to the other end of your circle. All right. First thing when I see this, anytime you're working with circles, you know pi is going to be involved. Okay. Sometimes they will say, okay, use 3.14. If they don't say anything, take a look at your answer choices. My answer choices right now, I'm seeing it's taking it to the 100th position. If it's not a whole number, it's mostly taking it to the 100th position. So that's telling me they're using 3.14 as their pi. So if I want the circumference is simply basically your diameter, or 2 pi r. Okay? It's 2 times the radius times pi. They're giving us our radius of 2. So that means we have 2 times my pi, which is 3.14. That's what it looks like they're using, times my radius of 2. Now, let's use our brains. 2 times 2, that gives me 4. And you're probably like, oh, okay, now I got to do all this long multiplying, Audrey. No, you do not. Take a look at your answer choices. You have 4 times 3.14, so it's not going to give you exactly a whole number. That's why A is out. Okay? That's why A is out. And Pog is also saying the last 2 is gone, right? Because we're going to get a 12 point something. So we can't get a 23, and we sure as heck can't get a 26. So your answer choice is going to be B. See how quickly we're getting it? Okay? Once you know the difference, and everyone's like, well, I got to memorize the formulas. Okay, if you got time before you take the test, definitely. Make yourself flashcards. Okay, quiz yourself once in a while. But if you think you're going to cram it all in your head, trust me, you're trying to put basically 3 years, 1 year of Algebra 1, 1 year of Algebra 2, and a year of, actually 4 years, a year of geometry, well, part of a year, and a part of a year of statistics. You're trying to cram all that math in your brain, okay? It's really hard to do it. But if you understand some of the logic and understand that you're going to tackle this test almost like, let me take a look to see what I can get, let me use my logic and understanding, that's the way you should go after these exams, okay? All right. Oh, thank you. Someone gift this lady. Thank you. All right, so getting close. Oh, sorry, didn't mean to. Hopefully I'm not reporting anybody. I just hit something. All I wanted to do was go to the other side. That's all I wanted to do. All right. So now for this next one, we have one complementary angle is 62 degrees. What is the measure of the other angle? All right, so here we go. Terminology. What is complementary? And I think we mentioned it here before, but just in case for those that are brand spanking new, I will go over this. Hey, Danny. All right, nice. Hey, Nicole, how are you? I haven't seen you for a couple of days. All right, so complementary, and this is the easiest way to help me remember. They always compare complementary with supplementary. Complementary begins with a C. Supplementary angles begin with an S. If you can remember, if I draw one line to touch both of the ends, my complementary, my C, turns into a 9. Complementary angles are two angles added together to equal 90 degrees. Supplementary, if I can draw a line to connect those two ends, I create an 8. Supplementary angles are 180 degrees. Okay? So if I'm finding complementary angles and I know one of them is 62, that means I can say 90 minus 62 will help me find the other one. Plus, knowing complementary, I know A is definitely out because that's 158. That's, yeah, no. Okay? I'll break it down like this. I don't know because I wasn't there. Now, if we're saying that one of the angles is 62, the other angle can't be 62 because that's going to go over 90. So C is out. Now you notice how they do us dirty. Let's just make it a difference of 2 degrees, right? But if we know that 90 minus 62, and you know that you're borrowing from the 9 to make that 0 into a 10, 10 minus 2 gives me 8. And you could stop right here and say, this is my answer. Okay? You can do it that way. If you want to continue on, you can continue on. But remember, this is a timed assessment. Not to freak you out, but take a look at some of the problems that we did. We did them rather quickly, right? And because you have all that extra time to possibly touch on maybe some of the harder algebra ones and see if you can get a couple extra points off of those. Just saying. All right? Yeah. They do this dirty. All right, so the next one is going to be a little hard to read. I know. Again, paper is expensive, but I will read it to you, okay? So it says the measure of one supplementary, Remember we talked about that? Angle is twice the measure of the second. What is the measure of each angle? All right, so if we have supplementary, that means it's going to equal 180 degrees. Remember that little trick that I had up here? Okay, if it looks like an S, connect it, and the complementary is the C. So they're saying one of the angles is twice the measure of the second angle. We don't know what the second angle is, so we're going to say 2x plus x, because the sum of these two angles is going to equal 180. They said it's twice the measure of the second one. We don't know what the second angle is, but all I know is one angle is going to be twice as big of it. So instead of you sitting here guessing and checking and trying to figure it out, we can actually do the math. So 2x plus x, there you go, gives me 3x, which is going to be hard for you guys to see. So I'm going to squeeze it over here. So we got our 3x, okay, equals 180 degrees. So now, isolating our variable, divide both sides by 3, okay? So if I look, I got x is equal to 60. Now, it's kind of hard to see the answer choices, but I'll read them to you. We have 60 and 120. We have 60 and 130. We have 45 and 90. And we have 31 and 61. So since we know supplementary angles is supposed to equal 180, that means my totals that I have here, they should equal 180, right? So even if you can understand this trick up here, carry that thought process down to this problem. So all I know, okay, 60 plus 20, that equals 180. That's a potential. 60 plus 30 does not equal 180. Boom, you're out. Okay? 45 and 90, that doesn't equal 180. Boom, you're out. 31 and 62, let's not insult each other. That's out. Okay? So my answer is going to be A, 60 and 120. All right? Whole bunch of A's. Good job. Right? Okay? So how are you feeling so far? How are you feeling about this? Okay? I know some of you guys like, man, this is mad easy. Some of you guys like, I think I finally get it. And some of you guys are probably feeling like, oh, okay, I can do that. How did I get the 2x plus c? I got 2x plus x. Is there an x next to the c? Yeah. So since they said one of the angles is twice the measure of the second one, they didn't give us any numbers. So it could be anything. So I just said, okay, let one angle equal x, and the other one is twice as it, so I just say 2x. Okay. All right. Okay. All right. Hey, film artist, how are you? Passing the GED? Well, it's not really the books. It's your dedication to it. Because most of the books are basically the same. I mean, some people are just like copy and pasting and they're just changing the cover. But the one I use is Kaplan. That's the one I use for my students. So just to get some of the practice problems. Okay. Alaska fisherman. Aw. All right. Okay, so you're taking college algebra next week. This is great. Awesome. You're going to love the next part that we do. Because that's in there too. Why am I watching this? I think this like 2 years ago. I know, Brianna, it's addicting. Welcome. Drew you into my web. All right. Now, the next one, let's see if we can go down below. Here we go. So we need to find the perimeter. Let's see if I can make this a little bit. Oh. What? Flash goal. What is all this stuff? Ugh, craziness. All right, so we need to find the perimeter, okay? Hence the word rim. Let's keep it classy now. Okay, so this is the outside. So when you're doing the perimeter, all you're doing is adding. Okay, so this is the outside. So when you're doing the perimeter, all you're doing is adding all the sides. But one side is missing a little bit of info. All right. What's the length of this side? What is the length? So I'm seeing 22s, I'm seeing 32. Okay, what's the length of this side? A baby? We're seeing 8, we're seeing 8, we're seeing ocho, we're seeing 33, I'm seeing A's, I'm seeing 8. Good, I have Emmy, I have Sydney, all the Sydney's saying 29. Michael R, 32, I have 8, okay. Oh, I have a couple new messages that my thing is not getting. There we go, all right. The reason why everyone is saying 8, because I'm seeing some other numbers other than 8. The reason why from here, and if I extend it out to here, is 4. Then from here to here, as indicated on this side, is 4. So that means this whole entire side is going to be 8. So you got your 8, and your 8. So 8 times 3 is 24. Okay? What else is missing? Where's the 3 feet? Yes. So right here. Okay, we're missing that other 3 feet. Okay, so from here to here, because if this whole side is 8, from here to here was supposed to be 5 feet. That means this remainder has to be 3 feet. So that means we got 8 times 8 times 8 times 8. So we got ourselves, it looks like a square, right? So 8 times 4, that will give me my 32. Okay. All right, good, good. Make complete sense, right? All right, yeah, that's it. Sherman, easy. All right, so now let me shoot over here. Okay. So we're asking for what is the area. So it seems to me, based on what I've been seeing, when it comes to area, and also even when they're doing volume, they're always doing something with rectangular prisms because, one, that's easy to do. For let's say a volume of a rectangular prism is just your base times height, your length times width times height, okay? Just multiply all 3 of the numbers they give you. Now, when it comes to area, they will definitely do something with the area of a triangle. They will definitely do something with the area of a circle. Okay, they will also do something with a rectangle. And occasionally they might throw a trapezoid in there. Okay, so the trapezoid is like an occasional type thing. Okay, so we're trying to find the area. And I think some people, it's the base times height divided by 2. That's the triangle. Base times height divided by 2 is the triangle. I think that's Heidi. Okay. All right. Ish is saying it's 110 divided by 2 or 3 by 2 for the triangle. If you know what the area of a rectangle is, that's base times height. Dividing it by 2 will give you the area of a triangle. So now you don't have to memorize so much. If you can remember the rectangle is base times height, all I know is a triangle, you just divide it by 2. Okay? But for a trapezoid, you got 2 bases. You have this 7 centimeters, and then you have this 15. So it's going to be your base, like base 1 plus base 2. So basically your top and bottom. Divided by 2, multiplied by your height. Okay? So you have your 7 plus your 15. Okay, so that gives you what? 22? And then you're going to have your height, which is 10, divided by 2. So this is how I tackle it. We have our 7 plus our 15 divided by 2 times my height of 10. Since I'm multiplying my height to this loveliness over here, I can cancel this out to make it a 5. Okay? This is multiplication. So with this 10 and with this 2, I can actually divide them out or simplify them. Because 10 divided by 2 will give me 5. And then I have my 7 plus 15, like I said, we have our 22. And then our 22 times 5, I know it's going to be 5 times 2, and that's going to end me with a 0. So if I know it's going to end with a 0, right away, A is out because it ends with a 2. B is out, it ends with a 7. So it's either going to be 6, C, or D. Right away, it will be C. Because there's no way that it could be 220 with those dimensions. Okay? And another thing that you can do, if they're ever checking for area, look at the measurements. If you know these are out, then you just cross those out. But if one said centimeters cube and this one says centimeters squared, that one's done. That's your answer. Okay. Yep. 22 over 2 would be allowed. TikTok just knew you had to study. All right. Next one. This one got a couple of my clients. All right. You have half a cherry pie left after your holiday party. You cut a slice with a 30-degree angle and put it in the refrigerator for your roommate. You eat the rest of the pie. What was the measure of your piece of the pie in degrees? Let me see what you can do. Well, Sherman, this is how I do my thing. Because there's a lot of people that rush through stuff. And you can go to their platforms. You don't have to. Right? Right there. So you don't have to stay. No one's keeping you here. Okay, so I'm seeing some A's. I'm seeing some B's. Okay, well, right now I'm seeing some A's. I'm seeing some B's, which is interesting. I don't see too many C's and D's, or if any. Yeah, well, here's the thing, Sherman. There's a lot of people from different places, different learning styles that are here. If this is too much for you, you can go. You don't have to stay. This is not Squid Games. Like, we don't have to sit here and tolerate. All right? Oh, greatness. How are you? Yeah. Yeah, well, in ChatGPT. You can't take ChatGPT with you during the test. That's pointless. Okay. All right. Okay, so think about it. Most cherry pies or most pies is a circle. If you ate half of it, okay, half of it is 180 degrees. Half of a circle. You take 30 degrees. So if you look at it, half circle, 180, you set aside 30. That means you're going to have 150, a nice, huge piece of pie, which gives you A, 150. All right? Okay? All right? How are you guys feeling? How are you feeling? Okay. Yeah, I'm not going to go in the area of planes. Yeah, see? Just nice, relaxing. Good. Good. Oh, thank you for the gift. Appreciate that. Okay. Well, good job. You're feeling like a champion. Love it. All right, good. All right. So this is a mixture of geometry to help people, especially the ones that are going to the ASVAT, because I got another person who I was helping, again, just a one-day jobber, just to tweak some thinking, and she passed the test. So she's doing what she wants to do. She reached higher than she expected. It's amazing. So people are doing it. All right, so a couple more. All right, a right triangle. Okay, think about this. A right triangle acute angles measure at the ratio of 1 to 3. What is the measure of the acute angles? Right away, which ones can I eliminate? Right away, which ones can I eliminate? Right? It's been a month. It's all right, Michaela. That's all right. I'm glad you're here. All right? Okay, which ones? D. We can definitely get rid of D. 1, we're saying a triangle. This is saying 190. That's more than 180 degrees. That's how much the triangle's worth. Okay? What else could we get rid of? All right? Blink saying A and D. Okay? There's a lot of people saying the answer is B. All right? So we can get rid of. You see how when you take these tests, process elimination. All right? So a lot of people are saying B. Okay? Right, because there's no 90 degrees in A. Exactly. Good. All right? So if we got this, we're looking for something that's going to give that ratio of 1 to 3. Okay? Hey, Josh. Someone's going to give us that 1 to 3. So which one? I think some of you guys were telling me the answers earlier, but then I was mixing it with which ones you can get rid of. All right? In a second. All right, here we go. So what do you think? What do you think the final one? You saying A or you saying B? I got some people saying B with the question mark. So how you can tell, because even if I add these up, they're both going to give me 90 degrees, so I can't use that trickery. But I need to know if it's 1 to 3. If I take this 22.5 and I multiply it by 3, will it give me 67.5? There you Pog champion. There you go. Again, you're in my mind. So ratio 1 to 3, yes. So that means that lower angle, the smallest one, if I multiply it by 3, will give me like 3 times the amount. So 22.5 times 3 gives me that 67.5. Okay? So yes, that is my answer. All right. And this one's going to be our last one for the geometry. Then we're going to see if we can do some rationalization. All right, so Evelyn is measuring a 50-foot triangular perimeter on this the corner of her yard so she can plant what is it? Parmesan? Anyone know? A fruit, I'm assuming. Even if you guys wrote it on there, I would be like, yeah, I don't know what it is. All right, if two sides of the triangle are equal and the third side is 5 feet longer than the equal sides, what is the length of the third side? Okay, so they're saying the perimeter is 50 feet. Okay, two sides of the triangle are equal. So it looks like we have an isosceles triangle. This side's going to be equal to this side. This is my longest side. And the third side is 5 feet longer than the equal sides. So that means this is going to be equal one length, this is going to be equal one length, and this is going to be 5 feet longer than the equal sides. So how are we going to set it up? So Grace Elizabeth, how do we set it up? It's a fruit? Okay, thank you. Oh, permission. Oh, permission. Okay. All right. Well, thank you. I have to look it up because I've never heard of it. All right. Yes. Good. All right. So if you have your 50 feet, because you know the total of it's 50, if you subtract the 5, because we said 5 of it's longer, that gives me 45. All right. But we're saying we got 2 of the same sides, right? So if I take that 45 and I've divided by 2, is it going to give me 20? Why should I divide by 3? Didn't it say it had 2 equal sides? Oh, because we only took the 5 longest, but it says 5 feet longer than the equal sides. So we're still dealing with 1, 2, 3. So if we divide that out by 3, for 1, that gives me 1, and 5, that gives me 15. But is that my answer? I'm seeing 20s. Like, what's going on? We got 15. Oh. I love doing that. All right, so because they said the third side is 5 feet longer than the equal side, the 15 is measuring the equal sides. But we're looking for the length of the third side. So it's going to be 15 plus the 5, which gives me my 20. But notice, 15 is one of those options. You see how they do you dirty? Okay? So my answer will be 20. Okay, you see how it is? Yes. So my suggestion, when you get word problems like this is usually like closer to the end, or it might pop up here and there. Remember, if you can do well with the other problems, that's awesome. Then take your time with this. Really take a look at, and when you get an answer, go back to the question. And the question is, what is the length of the third side? All right. And then you're like, oh, wait, I forgot I had to add the 5. And then you can get your answer. Okay. So those were some that I noticed this week that a lot of people had some kind of issues with the geometry. So now, as I'm going to set up for the next part, in the next part, we're going to go and flip a little bit. So we're going to go into rationalizing the denominator. Okay, a lot of people were having problems with this. So we're going to kind of walk ourselves through. So if you want to tap, you can tap a little bit. Yep, I know. Reading the whole question, It's all kinds of things. And yep, we're going to switch out. While you're out, stay here. I'm out. Nope. Sit your butt down. Because here's the thing. I'm going to break it down to the point that you're going to be like, okay. That's why I take my time here. We have it nice and chill here. If you're a type of person that you like getting the answer really, really quick and you're getting frustrated because I'm taking too long, you don't have to stay. No one has you kidnapped. You're perfectly fine. All right. Here, I focus on a lot of people that you went through trauma when you were in math class. And now you're kind of putting that trauma onto your kids. So the reason why I'm on here is to show you that, yes, you can still do math. All right? You can still do math and help your kids out. But we just have to take it step by step. All right? So now, when we rationalize the denominator, this happens when you have like a square root in the denominator. Because there's certain rules. We don't like to have fractions underneath a square root. We definitely don't like to have decimals underneath there as much as possible. We don't like to have a square root or any kind of root, hence the name radical, in the denominator. So when we end up having one in the denominator, we're going to do what's called rationalize the denominator. Okay? Tomorrow for geometry? Good. Hopefully that was helpful. Okay. Thank you for staying. Right. We need to energize our brain. We need to exercise our brains once in a while. We all want to exercise our body. Everybody want to have big boobs, small waist, big butt. But then we're not exercising our mind. Okay. That's a part of the system as well. So in this case, we have a square root of 5 in the denominator. In order for you to rationalize that denominator, I need to multiply the numerator and the denominator by that said radical. Because whatever I do in the denominator, I do in the numerator. Okay, let me zoom in a little bit. So let me show you why that's possible. So now, when we multiply radicals with radicals and whole numbers with whole numbers. But if you notice in the numerator, I can't basically combine them. It's not going to give me a square root of 10 because 2 is a whole number and square root of 5 is a radical. So it's like they can get close to each other. It's like they're dating, but they're not dating, Like they're together, but not together. You know what I'm saying, right? So they're really close. In the denominator, though, this is a radical times a radical. So we can combine those through multiplication, which gives me the square root of 25. But the square root of 25, that's one of those perfect square roots. So that can be broken down. So the square root of 25 is 5. And I know there's going to be some people that's like, oh, it's plus minus 5. Pause. It's only plus minus when you're doing with solving. Okay, that's when you put the plus minus when you're doing that whole square root method to solve for x. We're not solving, we're just simplifying, okay? So in my numerator, it's going to still be 2 square root of 5. And I know you're going to be tempted, just like that nice piece of chocolate cake that you always want to eat, right? But you can't simplify this radical of 5 with that whole number of 5. They're two separate worlds. Okay? They can hang around each other, but they can't be with each other, if you know what I mean. So this right here is your answer. All right? Okay. All right? Well, it wasn't under the radical. Right. Okay? If it was under a radical, yes, you can do that. You can simplify it. Now, don't forget the shortcut. So for those that don't know, if you're multiplying a radical and it has the same, what's called a radicand, the radicand is what's underneath the square root. If you have the same number underneath the same type of root, you will get just that answer without the root each and every time. Okay? If you don't believe me, so if I wanted to do the square root of 6 times the square root of 6, instead of me doing the square root of 36, and the square root of 36 is perfect and it gives me 6, I can just go from here straight to there. Okay? It works every time, but it has to be the same type of radical. Could be a square root, could be a cube root, doesn't matter, but it has to be exactly the same, and you have to have the same radicand underneath. Okay? All right. Favorite things to solve? Oh, that's good. Okay. So you can't times the 2 and the 5. Nope, because it's not a 5. It's a square root of 5. So I can't combine them, Danny. All right. What does square root mean? Okay, so we're going to have to go further back. All right. For any kinds of root, like if you say it's the cube root and then it has to be 3 of them. Okay, no, I mean the 2 on the top and the 5 on the bottom. No. You can't touch those. Can't touch the 2 and the 5. Okay. Yep, can't touch the 2 and the 5 because the only thing that 2 and 5 have in common is 1. Okay. All right. So now let's try. Let's see if we can try this one. So if we have, let's try this. Okay, so we have 3 square root of 25 over square root of 4x. Okay. 3 times the square root of 25 over the square root of 4x. Okay, so let's take a look. Here, you have your 3. Now, square root of 25, we can break that down. That's one of our perfect squares. And since it was 3, the square root of 25, that means 3 times the square root of 25. So we're still carrying that pattern over. 3 times 5. But then, if you look at your denominator, you're like, oh, wait. We can do something with the 4x. But we can only do something with the 4. If I want to, I can break this up into their own radicals. I could say the square root of 4 and the square root of x. Square root of 4, that gives me 2. So I have the 2 of the square root of x. And I can combine the 3 and the 5. I can multiply those two because they're both numbers. So 3 times 5, that gives me 15. But what's wrong? Okay. What's wrong? Okay, what's wrong? That's square root. Good, Jamie. Thank you. All right, so that's square root. Oh, I'm getting all my stuff. Gotta solve for x. The x, the square root in the denominator. Okay, so we definitely have to. Can't leave that rational down there. Good. So the only thing that I am going to use to rationalize this is not the 2 and the square root of x. It's just the square root of x. Because since we got multiplication going on down in the denominator, because we got 2 times the square root of x. So we just really need to rationalize just that square root of x. So what happens in the numerator is you have 15 times the square root of x. So that gives me 15 radical x. Okay? They can get close to each other, but they can't blend. All right? So now, if I do my shortcut, I got my square root of x times the square root of x. And just like everything else, remember this? If they're exactly the same, you will get the answer without the radical. So square root of x and square root of x will give me x, and then I just bring over its 2. And I know for sure you're going to be like, okay, cancel out the x's. Because we got the square root of x in the numerator and we have an x in the denominator. They are not a part of the same worlds. One is rational, one is irrational. Okay, so we can't break it down. And then I look at my 15 and 2, unless it's going to give me a nice whole number, all right, I'll do the division. But 15 and 2, that's going to give me a decimal. Not a huge decimal, but still a decimal. Let's keep it in its true form. Okay, let's keep it in its true form in that fraction form. So this is your answer. All right. Okay, of course. I got a couple more. I got more than just one more. All right. So before I get into the next bout, let's take a look at, okay, we can do this one. I think we can. Yeah, we can try this one. So we have square 49 over square 81. Actually, I'll put 2 of them in there. So square root of 49 over square root of 81. Can you do this in the calculator? No. Because if you do it in a calculator, you're going to get decimals for the radical, and it's going to be overwhelming. Okay. All right. Okay, so Georgia, hey Georgia Peach, welcome in. All right. So Janice got her 7 and 9. Jamie got 8 and 9. Switched it to 7 and 9. Okay, square root of 7 and 9. Close, Nicole, very close. Oscar 7 and 9. Thanks for the follow. Michael 7 and 9. Jordan 7 and 9. Hitch 7 and 9. Okay. Key things. Good. All right, Frankie Frank, somebody, anyone at what point in life we need to use this in math? Okay. I've already explained that multiple times. So here's the thing. I'll say it again. Now, everything you do has math. I can't even speak. Has math involved, right? Everything you do. Getting up, the calisthenics of you getting up from your bedroom to the bathroom, the brain power, everything. Now, I know there's a lot of apps nowadays that will take the place of doing all this mathematics. Totally get it. But then, I don't know what you want to do with life. I rather you say when giving any kind of test, because now they're putting problems like this and other things in apprenticeship to be electrician, apprenticeship to be a masoner, apprenticeship for plumbers. They're putting a lot of algebra just to weed people out. I don't want you to be weeded out. Everyone always says, what are you going to use in real life? I don't know what you're planning to do in real life. But they are starting to put algebra into interviews just to be a secretary. One of my students did that recently. And she's like, I had to do a math problem. I know all I'm going to do is answer phones, but why was I doing a math problem? So, and it was an algebraic expression, and she had to break it down. So, to answer your question, I know there's times I feel like a hypocrite. But at the same time, I'd rather you go into a situation and say, I've seen this before, and let me see if I can break it down, versus, what the hell is this? Okay? All right? All right? Okay. It does. It does. If it doesn't come back to haunt you, it's coming back to haunt your kids, and then you're going to have to relive that to break it all down for them. So it's crazy. So we are correct with 7/9. Since the square root of 49 is a perfect square root, it's no longer underneath a radical. Okay, that's how we got rid of the radical. Same with the square root of 81. That was a perfect square root, which gives me 9. So there is no need for the radical. All right, so we got that one. So now let's step it up a notch. Okay, just step it up a little bit. So now this time, we're going to be dealing with some expressions. And you're like, okay, I thought that's what we were dealing with. Oh, yeah. But it's going to be a little more intensified. You're like, no, yes. All right, so let's do this. So we have 2 over, let's start out with the square root of 3 minus 2. Okay, and you're like, oh, okay, so now we don't have just the radical in the denominator. Now we have an expression, radical with a whole number, and there's an operation in between, okay? So in order for us, like we said, we can't have, or we don't like having, a radical in the denominator. So we have to cancel that out. So what you're going to use is called the conjugate. Okay? The conjugate. So with the conjugate, you always look directly at, I'll put my little eyeballs on here. You always look directly at okay? Always directly at your denominator. That's where you're looking at. Now, the conjugate, if I may, we have the square root of 3 minus 2. The conjugate of this is the square root of 3 plus 2. I know, blew your mind. Completely blew your mind. Okay? And we're going to multiply it. So the square root of 3 plus 2. All right, so this is your conjugate. The conjugate is basically your denominator, and you just switch the signage. That's it. Okay, that's all you got to do. All right, yep, just one. Yep, so the goal is to get rid of them out of the denominator. Good job. Way to help each other out. Yep, conjugate's a throwback. Yep. So now, the way that I would love for you guys to solve it. I know everybody's like, yeah, let me just jump right in. Take it piece by piece. First, work out the numerator. Then work out the denominator. Put them back in a fraction form and then see if you can simplify. All right, so let me show you. So it's 2 being multiplied by the square root of 3 plus 2. So we basically have a distributive property going on right here. We're distributing that 2 to everything inside of that parenthesis. So this will give us our 2 square root of 3 plus 2 times 2, 4. Okay, so my numerator is pretty much straightened out. So now, here comes my denominator. I'm going to show you 2 ways how to solve your denominator. So one of them, and I'm going to take it and put in a different color. Do my green. So what we could do, this is the long way. And I like to give you guys choice. So you get to pick and choose what you want. So if I were to do the distributive property, I got the square root of 3 times the square root of 3. Okay? Same radical, same radicand. So that means it's just going to equal 3. 3 times a positive 2, remember, they can get close to each other. So since it's positive, it'll be plus 2 square root of 3. So now I'm going to distribute the negative 2. So now negative 2 times the square root of 3 gives me minus 2 square root of 3. And negative 2 times positive 2 gives me a negative 4. What's happening? Yes, we're going to FOIL. Why did you solve the back and not the front of the numerator? We solved the whole thing. Because remember, we did the distributive property. 2 times the square root of 3, that's where 2 square root of 3 came from. And 2 times 2, that's where the 4 came from. Okay? All right. All right. Then cancel the same. Yes, right here in the center. We got like terms. Because both of them are rocking the square root of 3. So that means I can combine their coefficients. A positive 2 and a negative 2. They cancel each other out, giving me 0, including the radicals. Okay? All of that is gone. But what remains is 3 minus 4. And 3 minus 4 gives me a negative 1. So this is going to be my denominator. So I have my 2 square root of 3 plus 4 over negative 1. Or you could just change the signs. Divide everything on the numerator by negative 1. So that will give me a negative 2 square root of 3 minus 4. Either one will work as the answer. So as I mentioned before, there's another way to handle the denominator. So let me rewrite this. I'll just put it in black. So we have square root of 3 minus 2. Square root of 3 plus 2. Another way to solve this denominator is we could multiply the first 2 terms in each parenthesis. Okay. Square root of 3 times square root of 3. Remember, that gave me a 3. Then we can multiply. Let's see if I can find. I'll just use this one. Then we can multiply the last 2 terms. which gives me negative 2 times positive 2, which is a negative 4. All right. So if you have your 3, you have your negative 4. I'm sorry, it looks like I'm doing multiplication, but I'm not. It's really, I just put the negatives around there. Okay. So 3 plus a negative 4 gives me my negative 1. Okay. You get the same answer. Okay. Does this method work every time? Yes, it does. How did you get the square root of 3? How did I get the square root of 3? Oh, well, it came with the problem. If you meant this one, this is part of your conjugate. So the original problem had square root of 3 minus 2. The conjugate is the square root of 3 plus 2. Okay. All right, no problem. You don't have to apologize. You can, if you've got the difference of squares. You can do that. But sometimes not all of it handles difference of squares. Okay. Yeah. I like this one. The whole page, please. Nope, I'm not showing the whole pages anymore. Because now Audrey's notes is alive and well. Unfortunately, I have to do it this way, people. I have to do it this way. Instead of me doing subscriptions, this is what I do. Okay. All right. I think I have enough energy for one more. Okay. Maybe one more that's going to be slightly intensive. Slightly. Or maybe a really intensive. We'll see how it goes. But we're going to see if we can get with the rationalization. So I'm going to use the other side just so I got some room. And this will be our last one for the evening. Okay, so we got 5 is going to be my numerator. And then we have 3 times the square root of 5 plus 2. Okay, plus 2. Yep, that's all it is. If it's the same radical, the same radicand, especially the square roots, it will give you the radicand without the square root symbol. On both of that, and just multiply 3 and 3 and square it again. Yeah, so I'm skipping that squaring it again step. That's all I'm doing. I know. We drag you right back in. Yes. Hey, Candy Girl. Yes. All right. So let's do this together. What is my conjugate? If you can type it up. What is my conjugate? So what would be my conjugate? Okay, negative 3 square root of 5. So 3 square root of 5 minus 2. There we go. I think that's what you were trying to say. So 3 root 5 minus 2. Yep, minus 2. There you go. 3 root 5 minus 2. 3 root 5 plus 2. Not plus 2. Always the opposite, Cookie. Okay, minus 2. Good, Jamie. I think that's Aunt's Girl. Okay, good job. Candy Girl, good job. There we go. All right, so we are multiplying the numerator and the denominator by our conjugate, which is 3 root 5 minus 2. Whatever you do in the numerator, you have to do in the denominator. All right? Okay, so now, we really want to just focus on one at a time. Let's do the numerator. Okay, let's shoot over to the numerator. So that means you're taking that 5 and you are distributing. Okay, you're taking this 5 and you're multiplying to everything. So in this case, our numerator will be 5 times the 3, whole number times whole number. So we get our 15 root 5 minus 5 times 2, which gives us our 10. Okay, minus our 10. So now, good. Let's tackle our denominator. So this is when it gets fun. Because my denominator this time, I have a number that's in front of the radical. But like I said with the shortcut, we multiply the firsts together. And if you need to rewrite to see it, let's do it. Okay, so you have 3, the square root of 5, times 3, the square root of 5. So you can multiply whole numbers with whole numbers, radicals with radicals. So 3 times 3, that gives me 9. Okay, square root of 5 times square root of 5, that gives me a 5. Because 5 times 5 gives me square root of 25, and the square root of 25 gives me 5. All right? So we're multiplying these two things. Okay, we're multiplying like with like. So 9 times 5, that gives me 45. That takes care of the firsts. Now, we're taking care of the last. So our last is the positive 2 with the negative 2. Okay, so there we go. So 2 times negative 2, that right there will give me a negative 4. All right, so we basically have 45 minus 4, which a couple of you guys said gives me 41. So this 41 is going to be your denominator, and that 15 radical 5 minus 10 is going to be your numerator. So then this is when we put our answer together. We have our 15 square root of 5 minus 10 all over 41. So this is your very last part. Is there a number that 15, 41, and 10 all have in common other than 1? Okay, no. Good, no. Okay, other than 1, they do not. Okay, first of all, you have 2 odd numbers and 1 even. Yeah, that's never a good flow. All right, good. No. All right, so that means this is your final answer. I know it looks really weird, but that's what we're doing. Yes, as is. Okay, so I'm glad you guys came over. You know, today was a long day, like long. But I finished it out. on a good note because I finished out with you guys. Yes, I am definitely going to be passing out soon. Because I got to do it again tomorrow. And that reminds me, tomorrow I'm going to have to come on live early because my California kids, all of a sudden they say, we got one more exam and then we got finals next week. I need help. So that means 10 o'clock, I am actually going to be not physically in California, but that's where I will be. So I'm actually going to come on live at 6:45 p.m. I know. But if you can't come, that's Eastern Standard Time. If you can't come, I will totally understand. You know I'm going to have the recordings. You can go ahead and go to my YouTube channel. And for those that have subscribed, thank you so much. And for those that haven't, come on over. All right. All of my TikTok lives are there. Okay, just go subscribe to my YouTube channel, Audrey Codner at GED Math Tutoring. And if anything, if you want to do a Google review for me, I would greatly appreciate it as well. But if a lot of you guys, if you need a tutor, do not hesitate. You can contact me. A couple of my seniors, especially in Florida, are starting to wrap up. So I will be having some slots for the rest of May and parts of June. Okay. So if you do need a tutor, come on by. If you like my notebook, if you like how it's been designed, okay, I designed this notebook. I got sick and tired of my kids not having their notes already prepared. And you will see these notebooks. I have my actual notes on sale. Okay, it's called Audrey's Notes. Okay, so you can actually copy all my notes. Okay, you can just print it out and follow along. So what I did was, and next time I'll actually have a picture of a page. I put a QR code on each of the notes. So like say the notes that we just had today for maybe both sessions, there's going to be a QR code. You scan the QR code and the live associated with that page will come on. So you don't have to like, oh, which one goes for which? Does it go for this one? You don't have to do any of that. I did all that for you. And then you can follow along. You can use some of the examples. There's some of them that has extra examples that you could use. You can go ahead and do that. If you like this notebook, it's not just for notes. It also has a reference sheet from 1 to 200. If you have problems with understanding your factors and you don't know how to break down a square root or any of those roots, I got you covered right here. As I showed you earlier, you have like the operations terminology that's mostly used in word problems. We also look at the adding, subtracting, and multiplying of the integers, the rules for that. And then order of operations, internationally also US, the properties of exponents, which you guys will definitely need to do. And everything linear, quadratic is over there. As well as if we look at our trig, we look at our SOHCAHTOA, some of our trig identities for my pre-calc kids, as well as the volume, the surface area, and also arc length and arc sector. All that's in there. And drum roll, the unit circle. All right. So with all that, and then of course I'll give you some brain breaks because we all need a moment just to reflect, but without losing our minds, right? Or sometimes we can't use the technology. So you got a couple pages where you can share your relief. All right. So that's all I have. Thank you so much. Okay. In case she doesn't see it on her links. Okay. Is this book on Amazon? Yes, it is. So if you go to my website, GED Math Tutoring, I'm working on putting it on TikTok Shop. Trust me. Everything is a process right now, okay? Trying to do all this and tutoring and all that, it's a bit much because I am a team of one. That's it. No one does my posts. I do my own posts. I do my own videos. I do my own editing. I'm actually going to be a part of a summit the end of this month. So yeah, a lot of things are coming in. But yes, you can go on Amazon. You can look up Audrey Codner, my name, and you can see it pop up. Or you can go to my website and you'll look up Ultimate Math Notebook. I have 3 different covers. Okay, so this one is for 7th through adults, because the one that I have for the younger students, which is somewhere around here, it's time to clean the desk off, people. It's time to clean the desk off. The print is a lot bigger. You have like more of huge graphs because it helps the students keep track of their digits. Okay. All right, no problem. Well, thank you. I appreciate that. Was heavy for me, but you did. You followed along, L-Dub. I'm so proud of you. Okay. The fact that, and that was like mostly Algebra 2, end of semester stuff, but pretty decent Algebra 2. So you should be proud of yourself. You know, sometimes we just have to do some of the harder stuff and get out of our comfort zone to enjoy the beauty of life itself. All right. So I'm going to go and check up on my cats, making sure they are doing cat stuff that's not destroying my home. And but I will be on tomorrow night at 6:45. I will try to put a post up to give that reminders. And if you do want copies of Audrey's notes, book 1 and 2 is up and ready for sale. There is a bundle, which is a lot cheaper. But then you could pre-order book 3, which is this one. We're going to be probably done, if not the end of this week, meaning like Saturday, sometime the following week. Okay. And then I'll definitely do everything and put that up. And that's real easy to do. Okay. All right. Well, thank you guys. Have a lovely day. Thank you so much for tapping. Yes, thank you, Michael. Hopefully you got my message. I got you. As soon as I put it in print, you don't buy it. I got you. All right. All right. Have a lovely night, guys, and stay safe. Happy scrolling, and continue to be awesome people. Okay? You guys are great. The world needs more of you. All right. I know I only see part of you, but this part I like. Okay. Keep it going. All right. Good night.